Hey guys, what is up? I'm going to go through a few different things on the flat earth theory and the sun and how it's just impossible for anything to remotely work with the sun. We're going to look at the sunset and then some other things. Okay, so here's my flat earth model. Right here, everything is to scale. It's on a small scale. The sun in my model right now is 2,800 miles off of the Earth's surface, just so we're clear about that. And I'm going to give you a perspective from North America, or sorry, South America, somewhere in the northern point around here is where we're going to be looking at the sun from. So somewhere in here, we're going to be looking at the sun right away. So I'm going to give you that perspective right now. Let's take a look at it. So South America at the tip, we're looking at the sun right here. That is at 32 miles. This sun right here is 100 times bigger. Don't worry about that. Let me go back though. Okay, well, let's look at this sun a little bit better. Let me make sure everybody is on the same page. And let me zoom in on the sun. Okay, this sun is roughly in the path where it should be, on course with the flat Earth theory. Okay. Now the idea is that if you're standing somewhere on Earth, the further this sun travels away from you, it'll appear to make a sunset because it goes into a vanishing point. The further it gets away from you, the smaller it gets, and it eventually goes into a sunset and vanishes, kind of a thing. So, to show what it would actually take to make a sunset, I put out a whole bunch of suns here. Let me zoom in. I put a whole bunch of suns, guys. They're all in line with each other. That's what I'm trying to show you right now. If you kind of visualize, you can see they're all in line with each other, going straight out that way. So just to give you an idea again, this sun is relatively on course where it should be. All these other suns, though, that are out here, they're off course and they're going away from Earth. So it doesn't matter which way you sent these suns away from Earth, they're going to go away from Earth, and we're going to see what it's going to take to make a sunset. And then I'll show you what the distance I calculated was. Don't mind, other things here in the picture or whatever. So I think, everybody's on the same page after that. So let's take a look at perspective again. Once again, we're in somewhere in the northern tip of South America. So we're looking at a sun here, 32 miles in diameter, that is on course of the flat Earth theory at 2,800 miles above Earth's surface. Furthermore, all these suns are 2,800 miles on a flat plane. So if we look, we can kind of see, here's one sun, and then, so the sun is, simulating that it's traveling a path. You can see it already looks like it dropped in the sky, and as we go on and look at the suns, it appears to be dropping out of the sky. They are all the same distance as I showed you. They were all in a line with each other. There is some out there, and it's getting lower and lower and lower and lower. Another thing you'll notice is they're getting really small. So they're all the same size, mind you, but because they're going into a vanishing point, they're getting smaller. So this one's pretty big, and then if we look out there, they're getting really small and really tiny. So let me render this and see what we have. Okay, so we can see sun here, a lot bigger. Down here, it's getting to the point where it's going to make a sunset or vanish, and I'm sure it did. I'm sure it did it, but we just can't see it beyond that because at the time it met the horizon, it would have just vanished. You can see it got smaller. Some of these are appearing to be bigger, smaller, or whatever. And I think that's because I had a few of them that were bunched up, and just because they're so, even though they're far apart, it's just from this perspective, some are appearing or higher or lower or whatever. Some kind of weird thing going on there. So as you can see, it somewhat made a sunset. So what is the distance of this? Right? Interesting. Now how far away is this? And I'll actually give you another render maybe if I can. Look at it maybe like that. Maybe I'll change it a little bit. There, it's kind of more in a straight line because we're looking a little different. You can see it kind of went down there. There's probably one down there, like I said. You just can't see it. So what is the distance? The distance is 160.9 million kilometers to that last sun that you were able to make out, or 100 million miles. Alright, so that would be the distance from Earth to that last sun in order to achieve this effect. And these are kind of rough numbers. I mean, give or take, probably 100,000 miles or so, maybe more. But to give you an idea, this distance, the distance that it took, is roughly the same distance that it is to globe Earth's sun. So they say our sun on globe Earth, that globe Earthers know, is the distance of that is 149.6 million kilometers, or 92.96 million miles, which is, works out to about the same distance to achieve this vanishing point sunset, if you will. So as you can see, to achieve a sunset on flat Earth, not looking good. It is impossible. You actually have to travel the distance of where our sun currently is on globe Earth in order to achieve this sunset. And more importantly too, you wouldn't have a day and night cycle for the rest of the world if you even were able to travel that distance. I mean, there's just so much things wrong with this, I shouldn't have to point it out further than this. I'm seeing that. Let's look at some other things though about the sun that aren't really relating to the sunset. I'm going to pull up another scene here, I guess. Let's go to this one. This one. Okay. So we know the sunset is impossible. How about the day and night cycles? Okay, how about that? Now, actually, I'll jump over to, or at least you should know that the sunset is impossible. If you don't, well, it's okay. I'm going to show you some things here about the day and night cycle. Okay, normal sun. I'll try to explain what's going on here. Let me bring this up. Okay, this is a normal sun. This is another flat Earth model, and this sun is radiating light like a globe-style sun would. It doesn't discriminate its direction. It just lets the light go wherever it goes because it's a globe, and it just, there's no focusing point of the sun. It just goes everywhere. And when that happens, two things happen. One is that no matter where you place this sun, your entire Earth is always exposed to light. So you cannot even have a day and night cycle, let alone a sunset with a globe sun. So there is no such thing as a day and night cycle with a globe sun, let alone a sunset. Because as you can see in my model here, I'll just kind of show you. I'll bring it down. Okay, at this point, you could have a day and night cycle. Your daytime, though, would have barely any light I'll just kind of zoom in. So your daytime would have barely any light except for the point where it's above the sun. So right now, this sun right here, we're having a day and night cycle with this sun, and this is a globe style sun, and you're roughly 500 miles, maybe 800 miles off the surface at this point. Any place that this sun traveled over would be lit severely, and other places would be dim. You would somewhat have a day and night cycle, like you could see, well, over here it's lit, but it would be a gloomy style lit, and it wouldn't be truly lit. The only places that would be truly lit would be, as it flew over, and it would just kind of get little parts of your country, or what have you. So it would be, drastically different day and night cycle than what we have with a globe style sun, and it would be gloomy in most parts, and then as it came directly over you would you actually get any true sun like as we know it. And this distance would be, like I said, somewhere around 500 miles. So it doesn't look good for globe sun, basically, is what I'm saying. Globe sun on flat Earth just doesn't give you the same day and night cycles at all. Now let's take a look at a spotlight style sun. Now a spotlight style sun does give you the day and night cycles, but once again, you're never going to have that sunset, but because it's a spotlight, right, it would give you a day and night cycle. Now this is like a sun, basically with a cone on the end directing the light so that the whole entire Earth isn't exposed to light. So in order to have a day and night cycle remotely to what we have, you would need a spotlight sun, or like a flashlight style sun that has a cone around the end. But once again, you're still not going to achieve the sunset, as I pointed out already.